And that's kind of interesting how the name came about. Some people asked that, back in those days when purchasing people wanted to find a company name, they still went A to Z. Mm-hmm. So we wanted something that was up in the A's, okay? So that was alpha. It's also the Greek word for first. We chose Q for quality. And so our tag name is what we live by is where quality comes first. So that's how Alpha Q came about.
Just a quick reminder for you to like, subscribe, and rate this podcast so we can get your feedback and know how to make it better.
Hey, it's Ari. Welcome to another episode of the Made in America podcast. I'm with Steve Prout, president of Alpha Q. Steve, thanks so much for coming on today.
Ari, thank you so much for having me. It's a pleasure to be here. I always enjoy your show.
Oh, thank you. Steve, it's the Made in America podcast, so we do start off with the same two questions. What do you make and why do you make it?
Glad you asked. What we make, we are in two business segments. So the first business segment, we do complex components and assemblies for gas turbine engines and helicopters. Examples of that are compressor cases, gearboxes, housings, front frames, fuel manifolds, some brackets that we do, and discs. We do them out of the aerospace alloys that you normally hear about: magnesium, aluminum, titanium, Inconel. Been in business since 1964, so been doing it a long time. Our second part of our business is Gaging, and there we go by the name of Glastonbury Southern Gauge. We're one of the largest producers of fixed limit gauging in North America, so we're proud of that. And we do that both in Colchester, Connecticut, and in Erin, Tennessee. And then our machining operation I talked about first, it's all in Colchester. So why do we do it? It's because, A, we're good at it. And we've been doing it for a while. So I said, we started in 1964, so it's almost 60 years. A lot of helicopter components are made out of magnesium, which a lot of people don't like to machine because it's very volatile, inflammable. So people sometimes stay away from that. That's not a good combination.
Yeah, I was going to say that's a rough combination, right?
It's a rough combination. So we're really good at doing that. And we kind of grew up on the machining side around Avco-Lycoming, which is the name from the past, from Stratford, Connecticut. And to think about the fact that they used to produce an engine for the tank, the AGD 1500, for both the Huey and Blackhawk helicopter, Huey and Chinook helicopters, and then also for the hovercraft that the Marines used to go from a ship to shore. So they produced engines for all of those products.
Hovercraft being that one with kind of the black skirt that you've seen that
yes,
one? Yep.
Yes, four engines on it. It can hit a beach doing 30, 40 knots as opposed to the chug, 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 put the ramp down and people go up.
The old World War II.
It's just incredible what it can do. So we started off there doing some simpler parts and kind of grew up from there. We followed, that company got acquired several times. So then it ended up being Honeywell and Phoenix. So we followed them out there. And then as that business kind of took a slightly downward turn, we looked for some additional work and we found Sikorsky. Sikorsky has a lot of magnesium work, of course, because of the strength ratio needed in a helicopter. So we started work with them, doing a lot of work in the transmission section. We're really good at that. Some of the parts we do are flight safety critical. Only they do it and we do it. Or sometimes just us. We're sole source supplier. We've been recognized by them as a elite supplier 5 years in a row, so we're proud of that. So I guess we must be doing something right there.
Must be doing something right.
So, and then you look at it in addition to it's what helicopters can do. Everybody's heard this story, but Sikorsky has a supplier conference once a year. And at that, they always have a speaker there, and they always talk about what's happening. So one of the years, it was the person in charge of the Los Angeles Fire Department for their helicopter fleet. And he talked about, this was right after the bad fires they had out in L.A. and Santa Barbara, where it burned a bunch of homes in Santa Barbara. This helicopter pilot talked about flying into smoke that you couldn't see anything through, actually filling up from swimming pools the water that they would then take and drop on the fire, because that was the closest source to get the water was a swimming pool behind a house. Oh, wow. Now, how would you like to be doing that in the middle of a fire? He says the only helicopter I would do that in is a Sikorsky helicopter, okay? This past October, we were at a conference, and Jason Redman was there. And he he was with SEAL Team 10 in Iraq. In 2007, he was involved in an ambush, he and his whole team, and he had to get medevaced out. And guess where he got medevaced out on? A Black Hawk helicopter, okay? He had half his face blown off. He had multiple wounds to his legs and torso. Lucky he lived, and he credited being taken out by medevac helicopter, because on the helicopter they could start treating him before he was then airlifted to the United States. And if you haven't heard about him, it's a tremendous story. And then, we also get things that come into us where, a Chinook helicopter is the body of the helicopter is sitting in the ocean, and the Zodiac comes screaming into it from people who have just finished a mission and they need to get away from there, right? Or other rescue type situations. So we feel good about, doing things that is good for humanity in a bunch of different ways. So that's good. From a gauging standpoint, as a manufacturer, we need the gauges.
Yeah, so talk about that for 1 second. I just want to get in the middle of this for just 1 sec. So, I love the connection to the larger mission, and the people that work at AlphaQ must be so proud of that, and I will get into that in a little bit. But before we talk about the gauging itself, I don't know that everyone listening fully appreciates what a gauge is and how important a gauge is to even manufacturing anything that gets manufactured. So could you just do a quick primer on the importance of gauging and what a gauge is, and then talk about how you guys make it?
So if you want something that's standard, it's interchangeable, and it's the same time in and time out, you have to gauge it. You have to know what it is and make sure it's the same. And you have to have standards to that. So in the United States, we have what's called an American Gauging Standard. And around the world, there's other standards too. There's an ISO standard, Japanese, et cetera. These standards typically go back to the late 1800s when manufacturing really started taking off. And the reason you can go to a hardware store and pick up a bolt and pick up a nut and make sure that any one of those goes on each other is because they were gauged, because they went to some sort of a standard. If you think about all the components that are in an automobile or in an engine, any type of engine, there's a lot of threaded components. Every one of those threaded components, for the most part, is checked with a gauge. And we make gauges that do that.
And I think something you and I talked about before, and I found this so fascinating, but I don't think many people realize that it wasn't always like it is today, where you could go to any hardware store, you don't care who made the bolt, who made the nut, who made the washer. We've got these sort of standard measurements, and if the item at home, uses a 3/8 inch, thing, you can get any 3/8 and it's going to go in. It wasn't always like that. And I think you have an interesting perspective. I wonder if you share that, because there's a lot of people out there, I guess even really us in our lives, but don't always appreciate how different that is than it was 120 years ago.
Yeah. So before the late 1800s, there was no standard. So everybody did things on their own. They came up with whatever they wanted, and they just kind of did it. Mm-hmm. And then Robert Briggs came up in the late 1800s with some standards for other thread gauging, especially in some other gauging. So that gave people something that they could go to and say, okay, we can make it to this specification. We have something we can check it to, and that makes it interchangeable. And that's where you then end up with what we is. And then that's also around, kind of the whole manufacturing revolution that kind of came along at the same time. And that went hand in hand, because without that, you're making everything one up.
That's right.
And that doesn't work.
No.
Obviously you can't do 16 million automobiles in the United States in a year and have non-interchangeability.
Impossible.
Or go to your local automotive store and buy a part and come home and the darn thing won't fit.
Right.
So now you can, because you know that those components have been gauged at some point along the way, and you know that they will work and fit.
Yeah,
so we're part of that marketplace.
Absolutely.
And so that's really critical for both us and for other manufacturers. And that's kind of why we do it, as well as we have some people that are pretty good at it. You got to be pretty talented to do that, because as I was mentioning to you, some of the tolerances of our product even make my eyes gloss over. We hold tolerances as close to plus or minus 10 millionths of an inch. And that's not a misstatement. That's 10 millionths, plus or minus 10 millionths of an inch. A human hair, the diameter of a human hair is 3 thousandths. So it's 100 times smaller than a diameter of a human hair is the tolerance we're holding that product to. it just is incredible. I even go through the plant and watch people do it, and I'm still amazed at how they do it.
It is amazing. And let me ask you a question about that. What is the advantage of those tight tolerances? Like, how does that show up in terms of the utilization of the product, or like, why is it so important that we're able to measure to those tight tolerances, and how is that a benefit to the products we make?
What you're seeing is all products today have tighter and tighter tolerances because it affects how good they operate and how well they operate and how well they do their jobs. So everybody is trying to get things that are closer tolerance. With that, if you're going to gauge it, the gauge then has to be better than what the tolerance is you're using. So we worked with a fuel control company one time that was in production doing fuel nozzles that had a 40 millionth tolerance. Okay,
So that means
that
it's
was
got
their
to be
part.
within a 40 millionth
40
of an
million.
inch.
So the gauge then, typically the rule of thumb is the gauge should be no more than 10% of the total tolerance, because the gauge has a tolerance.
Right.
So when I measure something with a gauge, it has a tolerance too. So it's not exactly
Tolerance, essentially
perhaps what
margin
it
of
is.
error, basically.
Margin of error. That's a
Right.
good way to put it. So typically they want 10%. So that meant that gauge had to be good within 4 millionths. That ain't happening. Okay, I'll tell you that. We're getting
Meaning
better, but
the-
that's not
The
happening.
big picture being the tolerance of the part is at least whatever is limited by the amount we can measure it.
That's correct.
Because if the gauge can't measure to 40 millionths of an inch, we don't actually know if we get there. So, right. So then if you got to have some, so
That's
I
right.
mean, I'm just trying to make sure everyone's sort of
That's
coming
right.
along for the ride here.
That's right.
That there's two components to being able to make something so precise, which is you need the tool to do it. So that's one thing. And of course, we know we've got lasers and different things that can work at really, really small increments. The problem is we also need something to measure the accuracy of that, right? So it's a two-component thing. It's not just the tool.
Exactly.
It's the ability to measure accurately.
Exactly.
And that's gauging.
That's gauging. And so the world has changed. We talked a little bit about technology. We talked about, the fact that recently we purchased 2 Mazak mill turns, 5-axis. The machines are incredible as far as the tolerancing and we're holding on those machines. We're holding plus or minus 2.5 tenths off them all the time. And again, you got to be able to measure that. And the machine tool has to be able to measure it. We're actually using touch probe systems in the machine tool itself. So in the machine tool, we measure it as well as taking it off and verifying it with another device itself. I'll also be honest with you that as everything has advanced, what we have found out is that what we thought we were getting and doing in the past, we didn't necessarily get.
Right.
So,
well, this goes back to we thought we were getting a certain level of precision.
Exactly.
But when we could measure better, we realized, oops, not quite so precise.
Not quite.
But let me just zoom out for 1 second, because I do want to get to some of these details.
Yep.
But I want to zoom out. I want to ask you some personal questions, and we can come back. But just to zoom out to connect with people that are listening that maybe aren't in the manufacturing space, is that one of the things that this level of precision has allowed us to do is achieve a level of excellence in products that we make that I don't know that people fully appreciate. And before this recording, you and I were talking, and I mentioned sort of one of the standout things in my mind that I think people can connect to is automobiles. And people that are 20, 25 years old probably don't remember, and it's even worse before I was born. But cars don't really break down. And I remember you and I were talking, I was saying, I remember the first time I opened up the hood of a new car that I bought, and the whole engine was covered in plastic. And it looks nice, but I thought to myself, well, it looks great, but it's going to be a bitch when it breaks down and I can't actually get to anything. But you know what I found out? They're not breaking down.
They're not breaking down.
I was telling you, I can't remember the last time, knock on wood, that I got like a flat tire. That I had to change myself. The run flats, you can drive them. And when's the last time I saw a radiator, kind of burst from overheating? The quality of the products and their ability to sustain functionality over long periods of time has greatly increased. And I think you attribute rightly that to the level of precision we've been able to attain.
Exactly. I'm old enough to go back to the days when you actually had to set the gap on a spark plug and had to set the points from the standpoint of the timing on the engine, okay? Not too many of your guests can go back that far. All right. But I can do that. All right. I remember doing that. And back then, if you had a car that would go 100,000 miles, you kissed it.
Right.
I mean, because it was so unusual. You know,
Correct.
cars at that time were going, 60, 80,000 miles and, that
Kaput.
was it. Or they'd rust out to the point where, you could see the floor from the inside of the vehicle. Okay. It's totally different today. I mean, if you don't get 100,000 miles out of the vehicle today, you're disappointed.
That's
I mean, that's kind of like the low level of everything. Okay. And then it kind of goes from there. I mean, we've all had vehicles, I'm sure, that are approaching I got one there right now that's approaching 200,000 miles and I'm still driving it. I'm still going to keep it.
Right.
So, that's the kind of thing that's happened. And then part of that is due to we're just better at what we do. We've obviously got a lot more knowledge about the things that go into it. And that's happened in the world of helicopters. It's happened in the world of, gas turbine engines.
Yeah, sure.
In
Airplanes,
all those areas. I mean, what we can achieve today is just unbelievable.
Yeah.
Boeing just had a device that came out of space that had been in space for 908 days. It was reused. This was the latest mission. And in total, it had been in space for 3,774 days.
Wow.
Can you imagine that?
Yeah, it's wild.
I mean, it's just amazing.
And just
some of
thinking about
stuff
the
that can happen.
entry, re-entry, the exit and
yeah.
re-entry and
Oh,
all
yeah.
the
Yeah.
pressure and heat. I mean, it's
yeah.
I think people, there's so much talk oftentimes about the good old days. They don't make things like they don't make things like they used to, and they're right. They don't. They just last longer now in a lot of cases.
Well, some things. I do have to say though, my mother had a refrigerator that lasted 50 years.
Yeah, that's tough right now.
Refrigerators don't last 50 years anymore.
Yeah.
Okay. Now, they have a lot of stuff on them.
That's right.
This one didn't have an ice maker.
Right.
It's just your basic, keep stuff cool or maybe freeze it. But that was it.
Well, once again,
But it
the
went
lack
for
of
50
precision.
years.
The lack of precision. It'll get colder. We just don't know how cold it's going to get.
Right.
So, Steve, it's clear you've got a passion, for this and what you do. There's just no doubt about that. It comes across so clearly. How did you get started in the manufacturing space? Like, what was the journey that got you to where we are today?
It was a very circuitous route in the fact that I grew up in Maryland on a tobacco farm. So coming to Connecticut and seeing the type of tobacco here, it's very different than what we did in Maryland. In Maryland, we cut all the plants, took the entire plant and put it up in the barn. So I came off of that kind of environment, then went to college and decided that I didn't want to farm. That was not for me. There was too many different things going to happen that were outside of your control, and obviously some pretty physical labor. So I went to school and got a background in finance. So actually my degrees and everything are in the finance side of the business. Started work first with a company that did packaging, cardboard packaging. Then went with a company that did food, which is called Giant Food. So Giant Food Retailer was one of the most advanced at the time. And then went with an electronics company that did things from secure communications to semiconductors to printing equipment to a whole bunch of different things. For personal reasons, I decided to come to Connecticut. And here I joined a company that was in manufacturing, and it ended up being the predecessor to Alpha Q. So Alpha Q started out as Reb Industries, or EB Industries, which was the initials for the gentleman that was major stockholder at the time. He sold the company in 1986. I joined in 1987. That's when we changed the name to Alpha Q. And that's kind of interesting how the name came about. Some people ask that, back in those days when purchasing people wanted to find a company name, they still went A to Z. Mm-hmm. So we wanted something that was up in the A's. Okay. So that was Alpha. It's also the Greek word for first. We chose Q for quality. And so our tag name is what we live by is where quality comes first. So that's how Alpha Q came about. So I joined the company in 87. In 1995, we acquired the Gage company in Tennessee. So that expanded our Gage operation. But we always had a Gage company here in Connecticut called Glastonbury Gage, and we had the machining operation. And it gets in your blood. You get around people that are really good at what they do. You think I'm excited, you should come to our company. I'm probably the least excited of the people that work there. And we're blessed by having some really good people. I mean, you don't do the kinds of things we do without a good engineering staff, good quality staff, people on the floor that know what they're doing. You can automate to a point, but it still takes the human element that really understands, really has the capability of what they can do. And we've been blessed with that. And to see some of the things we do on a day in and day out basis, it just puts a smile on your face, you know. And Gaging, to walk around and see the tolerances and some of the configurations and some of the things we solve for companies and for customers, it really is amazing. And we work with some good people. I mean, most of the people we work with, I got to say, are people that we enjoy talking to. Isn't that nice?
That is nice.
Isn't that great when you can have your customers be people that you actually look forward to when they call you?
Yeah.
You know, and of course you got to perform to do that too. Or
I was going to say, when you get 5 years in a row Platinum Supplier Awards, you know, that probably helps with them being nice to talk to. But yeah, that's
it
true.
does obviously. And with Rolls-Royce in 2021, we were their most engaged supplier. So I guess we talked to them a lot, right?
I guess so.
So that's been good for us. But, you know, it just gets in your blood. So I've been doing it for quite some time now.
When you think about some of the stuff that, you know, at work that sort of brought a smile to your face recently, can you like think about a couple of like things that happened that you like? Yeah,
absolutely. Absolutely. We had a customer come to us and said, look, we're in a real jam. We got a problem with a part failing in the field. I don't have time to go get a replacement casting, get you to machining, et cetera. Can you do this out of solid? So it was a titanium part. And of course, when you start out knowing that you're going to make a part from solid, you kind of design it a special way. This wasn't designed that way. And of course, they didn't want anything to be different because it was failing in the field. So nobody wanted to change anything, right? But they needed it right away. It had to be made out of titanium. We figured out how to do it. Okay. I mean, it's just a great feeling to be able to get a customer out of trouble like that and do it. We have another component customer came to us and said, look, we want you to make what you're doing at a higher assembly. But when you put this part with that part, your tolerance is 0. What?
What?
That's a lot smaller than a human.
That's a lot smaller. Yeah, exactly.
Okay? So basically what they were telling us is that each of the components has a max-min material position. You had to figure out what those two were.
No, you got to explain it. Max, min.
Max means the part can be this much bigger, this much smaller.
Okay.
To what their exact size is. Okay, that's your tolerance.
Okay.
You had to take those two tolerances and put them together and figure out where you could be. That's what you were allowed. And our guys figured it out. We did it. Okay. Then I've got a couple of young people that graduated from tech schools.
Yeah.
So we bring them in typically in their junior year. So they have a work share program where they can start in a junior year and then senior year, they work a few more hours, get credit for it. So we get to see them for 2 years and they come in and we can hire them. We got some young people that started that way. One took advantage of our tuition assistance program, went back and got an engineering degree and works in our engineering department. Guess what? He's a degreed engineer. 0 college tuition debt, okay, making a very good salary, and doing something he loves to do. What a great story, right? As compared to everybody else who's got all this mountain of debt. We got another gentleman who's 24 years old. He runs machines that are worth $4 million for us. Got another gentleman that came from tech school, said, hey, I kind of like the quality world. He's now running and programming a coordinate measure machine. That puts a smile on your face.
Yeah, I bet that does. Where are you finding these young people?
It's not easy. It's not easy. We've been lucky in the fact that Wyndham Tech in Wyndham, they have a very good program. We're close to the gentleman that runs that, Jim Carden. He does an excellent job. We've got a number of good people from there. Also, Ellis Tech in Danielson. A gentleman actually used to work with us, is the head of that program, Tim Milton. So we got some people from there, as well as Norwich and Groton. Also, one of our key executives is on the Manufacturing Council for Goodwin and their manufacturing program there. So we've got some people from there. Mm-hmm. But, I mean, we got to have that. We got to have that technical.
So let me ask you about that, because a lot of people want to do and have those success stories that you're talking about. How do you guys go about developing and then sustaining those relationships with the schools, you know, whether it's Goodwin or tech schools? How do you maintain and think about investing in those relationships so that you get the return from it in terms of these great success stories?
We have people that are in contact with them several times during the year. They also know if they really need something, they can come to us and we'll try to help them to the extent that we can. We also encourage them to have their students come to our facilities so they can see what it's like to work in a manufacturing facility.
Are you doing this through like the HR team? Are you doing it through the technical team at
We do it
Alpha
through
Q?
our production people.
Yeah.
Our production people are talking to their heads of their
So you're not doing this
programs
through
and-
like the recruiting approach.
We do that too. I mean,
Yes,
HR
you're getting there, but you're partnering them on the value add.
Yeah.
With sort of like, hey,
Right.
let us offer you something, and then we'll develop those relationships.
and let them come in and see what they're going to be involved in. It's it's not cranking a hang. In some cases it is. I mean, in the gauge operation, it's very high mix, low volume. So there we're doing a lot of manual equipment. I got to admit to that. And some people love to do that. Okay, it gives a great feeling to be able to do that. But we're working with very sophisticated equipment now. It's all computer controlled. So people have to be up to knowledge on how to do that. And the tech schools have to have that kind of equipment that they're learning on. So when they come to us, they're not totally blown away
Right.
about what's happening, but they get the sense of coming in and seeing the parts that we do, the types of things that we do. So that's been great. And, several people on my staff, they really work hard at staying in contact with these people and finding out, who are the rising stars in their programs. And obviously those are people you want to go after. And we're looking forward to doing that with our Colchester, local high school as they're developing their program and getting that going. Because as I said, that's going to be the key to this whole thing, in my opinion, to get us through this. And even with the levels that we're doing now, it's not enough.
Yeah. So let's take that. You're saying it's what we need to get through this. What's this, and what do we need to do?
This is the tremendous uptick in business that everybody is looking at. It's the tsunami wave of retirements that are coming along because, people have now gotten to the age where, they can retire. And if the market doesn't go to hell in a handbasket, hopefully they'll be able to. So there's a tremendous requirement. I can't think of a better time for somebody to be in our business. It's got a long runway. We need you. We not only need your physical ability, but your mental capability. It's challenging every day. Every day you come in, it's not exactly the same. And so we find people that if it's something they like, then they really get into it. And that's the people we're looking for, and we got to find those people. And with ACM, who we're a member of, every November they have a get together of the companies at. More recently, it's been at the Convention Center in Hartford. The morning is all about getting students to come in there and see what manufacturing is all about. So this last time, there was over 100 companies in that room. And the students for the whole morning got to come through, go through, talk to all these different companies, see what they do, see what's done, see examples. I mean, CCAT actually brought a couple of pieces of equipment in so they could see it actually operating, which is kind of neat. So we've got to get that kind of level of interest. I mean, I was actually listening to a gentleman speak from Electric Boat. They start at the 6th grade talking to kids.
Really? Playing the long game, I see. Playing the long game. Yeah.
But, they're projecting out, in the next 10 years, how many people they got to hire.
Right.
So...
And so, I mean, look, so, not that either of us are, policymakers here, but, there's a need now and in the future. So we got to sort of balance getting people in today as well as building the 6th graders for, 10, 12 years from now. I mean, what are your thoughts around filling the pipeline today? Because, you touched on some really important stuff, and I'm just going to reiterate it just to make the point again, which is it's an amazing time to get into this space, right? Because you've got growth in the business, so that's super helpful. You've got a lot of dynamic change, so it makes the work really interesting. And one of the things that I hear from people all the time is they get started in a career, whatever it is, then they feel like they're sort of capped because everyone above them is just, they got to wait for them to move on or whatever, where because of that sort of lost generation, of sort of my age group and around there that didn't know about manufacturing and did other things, there's a big gap where you get started now, you've got these, older experienced people who are willing to train and they don't have a lot of time left.
Right.
So you've got massive career growth opportunities. I mean, it's huge, but we got to fill it with people, and 6th graders aren't going to be ready to go to work anytime soon. So how do we what's the other way to attack it to hit today's need and build the future?
Well, I think, the number one thing you got to do is you got to entice people at a high school. So typically in these kind of programs between the 9th and 10th grade is kind of when they got to decide, where they're going to go and what direction they were going to go into. And so that's why we have, every year we invite those students to come in so that they can make an educated decision about which direction they're going to take. Because look, everybody's looking for people. You got automotive mechanics. I mean, every auto dealer is looking for people.
True.
You got HVAC
Plumbers,
people.
HVAC, sure, electricians.
If you can work with your hands and you want to do anything with your hands, boy, if you're not working, it's because you don't want to. Okay, so we're all competing for the same kind of resources. I quite frankly think that, and this is a little bit longer time off too, but we need a sensible immigration policy in our country. It's a shame of what's happening right now. And I don't want to get too much into politics, but it's a combination of things that's going to have to solve this. It isn't just one thing that's going to make it happen. And additionally, we have to be more productive. We have to use technology in our business so that each person can do more. And what they do multiplies itself. As I mentioned, these two pieces of equipment that we bought with a Palatech system and a quarter measure machine, one person runs that whole thing.
Yeah, let me two things. I'm going to talk about that in 1 second. I couldn't agree with you more on the immigration thing. I mean, look, the reality is the numbers don't lie, and we are just not having enough babies to be able to fill up the pipeline, no matter how great our education system is. It's just not going to happen. And you can just look at the numbers and see that, our death to birth ratio just keeps dropping. And I don't see a lot more families of 4, 5, and 6 being made these days. So that's really the place. The only way to fill that gap is either have more babies or bring in people from somewhere else. And I think to the extent that people can all across the world still want to live here, shame on us to not be able to figure out a way to solve two problems at once. So anyway,
and do it responsibly.
100%. I mean, it's not. It doesn't need to be a free for all, but we can't. Saying no isn't going to work either. So sensible policy, like you said.
Yeah.
I'll get off my soapbox on that. So let's talk about the hardware. So I mean, you're saying some words out there that people that are in the know, but I just want to explain. Talking about these palletized loaded machines. We're talking about very large pieces of equipment.
Yes.
That you load either raw materials or partially finished parts into the conveyor belt on one end, and then it automatically moves down the conveyor. We're talking about robotic arms, picking up pieces, loading up the tooling, putting it in the machine, running a program, finishing it, measuring it, putting it back on the pallet, moves back down to the next machine, rinse and repeat until all the operations are done, comes off the other end of the conveyor belt, basically done. And
in some cases it's done, in some cases still needs some.
Well,
but
done with those period of operations. And what maybe would have taken how many more machines themselves plus 4 or 5 operators, we're down to 2 or 3, two in your case, large machines that can do multiple processes in them, and one person running them. It's amazing.
It is amazing. And the other thing with that too is everybody is about uptime. The spindle's got to be turning before you can make any money, right? Or you're producing anything. So in our world, we do a lot with castings and forgings. We start out with castings that are very expensive, so you can't screw that up. You got to know what you're doing.
Well, you can't screw it up, but you ought not screw it up.
Well, so we have a lot of sophisticated fixturing that we go through to make sure that the part is held exactly the same way every time we introduce it into the machine tool. And then we obviously monitor the tools that are in the machine to make sure that they're doing what they need to do, and the program's the same, okay? But my point to all that is that you need pallets to be able to stay set up, so that when I go back and put that part on that pallet again, I don't have to go through that whole process of reorientating that, making sure it's in the right place and the part's going to be exactly the right way orientated to the machine. So in that system, I have 16 pallets that I have that feed those 2 machines. So I have 16 opportunities of putting something there that can go in a machine. So when the machine gets done and that part comes out, I don't have to wait to set up the machine again before I run the next part. The next part can come in because it's already on a pallet. It's already been tried out. It's already been tested, and I didn't change it. So it just goes in the machines. So there's several different benefits, not only just from a labor standpoint, but just the uptime that you can have on the equipment.
And probably accuracy and execution.
And accuracy, yeah.
And we know where quality comes first.
Yeah.
We got to make sure we're getting that
Absolutely.
right. Yeah, that's really amazing. And I mean, seems to me like you believe what I believe, which is this isn't a one answer solution. We need to figure out how to get people here now. We got to figure out how to train them, and we got to invest in technology. It's not one or the other. It's really all the above approach.
It's multifaceted.
Yeah.
And it's all the above. And there's more in addition to that, okay, when you really get into it. The way you start off doing things now has changed. We can do so
do you
much
mean?
more electronically and through computers about validating things.
Yeah.
You used to validate a process on the machine tool. You'd go out there and the operator would tweak it this way, you'd tweak it that way, and eventually it would come together, right? And he'd remember that. Okay, this is what I did, right?
Right.
Now we have elaborate, process sheets that go through everything that you do. So it's done exactly the same way. And before that ever hits the floor, we go through different CAD models to make sure it's what it's supposed to be. It actually validates what happens on the machine tool. So it tries to catch anything that might be big that's wrong with it. We actually 3D print and plastic some of the parts that we make. Obviously, this one's on a small scale, but to actual size. And we use those as a first piece through the operation just to prove the operation out. So I'm not working with a part that's, could be a good part and screwing it up somehow.
Right, which just saves on materials,
which
saves
doesn't
on
put
time.
a smile on my face, right?
No.
That doesn't happen. So it saves a lot. And so we have to use all the available technology to get as much out of it as we can.
It's really it's changed a lot since 1964.
Oh, it's night and day. I mean, we have pictures of people. It's kind of interesting in the gauge world. If you go back, the founder of Glastonbury Gauge used to work with Pratt & Whitney machine tool. And back in the day, they went to work with ties on, a white shirt and tie. That's what a tool maker was back in that day. That's how good they were, okay? And you look at those pictures and you say, wow, what pride they took in what they did, because it was all about that person.
Right.
Okay. Now, it's still a lot is to some extent, but we can certainly put technology in place to help with that whole process. So it's not quite as intensive as it was back then.
Yeah, and probably more likely to come out accurate and precise instead of just trying to remember. Right,
yeah.
Exactly.
Right.
Well, Steve, man, it's amazing what you guys are doing. Love the engagement. Love your passion and commitment. It's been really great chatting. You ready to convert to rapid fire round
Sure.
questions to wrap this thing up?
Sure.
All right, buddy. Here we go. Red Sox or Yankees?
I'm going to make you mad, Yankees.
Oh, why? I mean, Colchester, that's anyway, we'll offline discuss your poor choice of a baseball team. But moving forward, Starbucks or Dunkin'?
I don't drink coffee, so you can have that one.
Neither one. When you take time off, staycation or exotic destination?
I like both, actually. I used to always like exotic locations, but when you go to those, you tend to cram everything that you can in a day. So I would go from 6:30 in the morning to 10:30 at night and very little in between. So now we're also coupling that with staycations. You go someplace you can relax and just get immersed.
Try to avoid that feeling of needing a vacation after your vacation.
Yeah, right, exactly.
Yeah, I know that feeling. iPhone or Android?
iPhone.
Sports car or SUV?
I love both, but I fit better in an SUV.
Do you have a favorite business book?
My favorite business book is The Goal, but I have a couple other ones too. There's a book I was recently just finished called The Power of One More by Ed Mylett. And it's kind of a self-help book type thing to get more out of every day, to be more productive. I also found The Changing World Order by Ray Dalio to be very kind of insightful and kind of brought up some interesting things about how things keep repeating themselves over history and how societies end up doing that. And then when I don't want to think about anything, I read David Balducci.
David Balducci?
Yeah.
I'll have to check that out.
Yeah, you have to. He's got these characters that, one or two characters can solve any problem out there. The espionage, counterattacks.
Little 007 Jason Bourne. I like that. If you could do anything, Steve, other than be president of Alpha Q, and it had to be something else, but it could be anything in the whole world, what would you do?
I'd be a writer about travel or do a travel podcast.
Oh, well, you could. That's a second act you could still do, my man. Keep on that. Keep on it.
It's more like work. I want to get to my second act to be not so much work.
Not so much work. Steve, what's something that you learned early in your career, or early in your life, that you think's helped propel you to all the success that you've had?
Don't give up. You know, it's just like that power of one more. I mean, there's been numbers of times when you were faced with something that was just been easy to say, you know, that's it. I've had enough, you know, go do something else, just to keep going. So, you know, and sometimes it just takes that little bit extra. You know, what did Albert Einstein say? It's 5% inspiration and 95 perspiration.
Yep.
You know, and the other thing is, and actually I've learned this later in life, is life is a lot about perspective. Mm-hmm. You know, and Jason Redman, you know, who I mentioned earlier, he kind of talked about this after going through what he went through. He wears a T-shirt all the time that says "No bad day," and his whole point is about perspective. Yeah, I can get up in the morning and I decide to make this a great day. Stuff's going to happen. It's all how I react to it.
Yeah, I hear that.
So,
and I like that. You were saying that. I was thinking to myself, it's not no más, it's uno más, right? Not no more, just one more.
See, one of the things I like about you, if I could just interject for a second, is I've never seen you not smile and not be happy. Never.
That's awfully nice to say. I guess it's all about
that takes something, right? I mean, but you have the same stuff that happens to you that happens to everybody else. You know, your check engine light comes on when it's not supposed to, right? Your kids, you know, get into stuff that, you know, what'd you do that for? You know, this didn't happen right in business. Oh my God, you know, I can't believe somebody did that. You know, you go through all that too.
Uno más.
So obviously, you have a way to get a perspective about it all.
I appreciate that. It's very kind of you. What's one thing, Steve, that you learned later in life or later in your career that if you could go back and tell young Steve, and if he'd listen to you, make a real positive impact on his life?
It would have been, you know, to smell the roses more, to enjoy the journey more than I did. I was so hell-bent on getting everything done. It had to be done right now, you know, at such a frantic pace, to enjoy it more as you're going along.
It's not about the destination, it's about the journey. Yeah, man. That's Steve, it has been really great talking to you. You killed it. We're going to have to talk about the Yankees afterwards. But other than that, it was terrific, man. I really appreciate your time.
Okay, I enjoyed it. Thank you, Arnie.
Made in America with Ari Santiago is brought to you by CompassMSP.
Thanks for listening and spending some time with me today. My goal is to help build a strong manufacturing community, and it would be impossible to do without all of you.